Pacelli and Ben Flast about Atlas Data Federation. Have a great last talk.
Thank you. Hi, everyone, and welcome to .local New York. We're really excited to have you here for our session on the best practices for cluster query federation and ETL with Atlas Data Federation. My name is Taylor Pacelli, and I'm an Associate Product Marketing Manager here at MongoDB for Atlas Data Federation and Atlas Data Lake.
Hi, and my name is Ben Flast. I'm a Product Manager here for a range of our analytic and AI-oriented services.
Alrighty, let's get started here. All right, so today in just 30 minutes, possibly shorter, I'll try and get you guys out early for that happy hour reception. We're gonna begin by exploring our business use case that will serve as a reference point throughout this entire presentation. We'll then discuss the challenges that developers are facing when it comes to data integration and data management, and then introduce Atlas Data Federation and how it helps solve those challenges that developers are facing. Then Ben will walk us through a demo of how to use Atlas Data Federation in relation to the business use case we introduced. And then we'll discuss the newest updates in Atlas Data Federation that we released today at .local New York and we're really excited about. And then lastly, we'll summarize our main takeaways from the presentation before opening up the floor for Q&A. All right, so let's get started. So I want you to imagine for a second MongoDB Airways. And just like any other airline company that you may be familiar with, MongoDB Airways stores and collects a vast amount of data. They store customer booking data, so anyone that's booking flights on your website, customer profile data, so if they're making an account and saving that information for later, revenue data, so that includes things like ticket sales or in-flight purchases, your flight route data, that could include things like your flight durations or flight distances, baggage data, so that would include making sure that your luggage ends up on the flight that you're on, because we never want to lose our luggage, and is making sure it's under the correct weight regulations. They even collect data like your crew's work schedules and flight assignments, or scheduled maintenance for the aircraft, and so much more. But all this data isn't necessarily stored in one single location. It can be stored across multiple locations. So ultimately here, in order for MongoDB Airways to unlock its full potential, we need to find a way to unify this data and move it to a centralized location so that our teams can gain insights from it into their customer preferences or operations and ultimately drive business growth through data-driven decision making. So now I want you to imagine that you work for MongoDB Airways. You have customers that are booking flights, again, directly on your website. And then you also have customers who are creating their own profile with information like their frequent flyer number or loyalty program membership information for a more convenient way to book flights in the future. So let's say MongoDB Airways stores this data in separate locations. They have their flight booking data in one Atlas cluster, and they have their customer profile data in another Atlas cluster. Well, what if I want to get a holistic view of this data? And what if I also want to move this data to a centralized location like Amazon S3 so my downstream teams can extract insights from it? Well, this is ultimately where Atlas Data Federation is going to come into play. But before we talk about Atlas Data Federation and how it works, I want to take a step back and discuss the challenges that developers at MongoDB Airways was facing before a solution like Atlas Data Federation existed. So here, we have our data scattered across multiple locations like we've discussed before. We have our flight booking data in one Atlas cluster and our customer profile data in another. And ultimately here, we want to combine this data so we can get a holistic view and move it to Amazon S3, a centralized location for efficient storage and analysis. Well, beforehand, combining this data would require writing custom code or relying on third-party tools, and ultimately, this complex process was really time-consuming and diverted developers' focus away from more valuable tasks. And also, writing custom code ultimately led to higher infrastructure and development costs. And so MongoDB Airways needed to find a way to still unify this data, put it in a centralized location, without wasting any more of their resources. Atlas Data Federation Federation helps solve these challenges that MongoDB was facing by providing Atlas users the ability to combine, enrich, and transform their data as if it were all in the same place and format. They can execute federated queries across multiple data sources and then persist that data to their preferred location in their preferred file format, all through a single unified platform. So if we shift our focus now to the after state, you can see, again, our data is still scattered across multiple locations, our flight booking data in one Atlas cluster, and our customer profile data in another Atlas cluster. But instead of relying on writing custom code or relying on third-party tools, developers can instead execute a single federated query to combine and access their data as if it were all in the same place. And in addition to that, they can then persist their data in their preferred file format, in this case, Parquet, to their preferred destination, in this case, Amazon S3, again for efficient storage and analysis. And the result is a single view look at all their data. This is ultimately fast, easy, and really powerful. It solved all the challenges that MongoDB Airways was facing before by eliminating the need for custom code development, saving developers valuable development time. It enhanced developer productivity by allowing developers to spend more time on the valuable tasks rather than the intricate data integration and management processes they were experiencing before. And it also helped MongoDB Airways as a business get faster decisions and insights by gaining that holistic view of their information really easily. And also, this approach proves to be more cost effective as it minimizes the need for custom code development and the infrastructure costs that are associated with it. So now you understand what Atlas Data Federation is and what it does and why it's so valuable, but you're probably wondering, well, how does Atlas Data Federation do all of this? So really quickly at a high level, before Ben walks us through a demo and shows you how Atlas Data Federation works, I'm going to talk about it at a high level. It all starts with our data stores. Our data stores is where your data currently resides. Currently, Atlas Data Federation supports your Atlas clusters, Atlas Data Lake datasets, and cloud object storage offerings such as Amazon S3 and Azure Blob Storage. And the first step to using Atlas Data Federation is configuring a federated database instance. Each instance contains virtual databases and virtual collections that map to the data in your data stores. And this is super quick and easy to do. And once you map your data sources, you can then begin using MongoDB's aggregation pipeline to transform and query on your data as if it were all in the same place and format. And then the results of those queries can be persisted to your preferred location in your preferred file format, such as your Atlas clusters, Data Lake datasets, or Amazon S3, or queried directly to enable your downstream teams. So now I'm going to pass it over to Ben to showcase a demo of how to use Atlas Data Federation in relation to this MongoDB Airways use case so you can see it in live action.
Cool. Thank you, Taylor. Awesome. So I'll go ahead and click Start and walk you through what's going on here. So the first thing that's going to happen is I'm going to find myself at the database deployments page. Let's see. Is it going? No. There we go. Cool. So we are on the database deployments page, and you can see I have a cluster here that is called MongoDB Local NYC. And in a second, I will be going in to look at our collections. So if I click Browse Collections, it brings me into what we call Data Explorer. And on the left, you can see it's pretty simple. I have MongoDB Airways and a bookings collection. What I've done is, in the Atlas Triggers menu, I've created a trigger that runs on a schedule and just inserts random booking data into this collection. You see I have an array of locations. I create events that are of type booking that pull a random destination, and so I'm simulating the bookings, right? Once that's done, I have some data in my cluster, and I navigate over to Data Federation. And you'll see I have my new onboarding flow where I have this templated setup. I click the feed downstream systems, and I go in and see what feeding a downstream system entails. So I'm going to select a cluster, connect to the destination object storage, and then I'm going to specify the frequency and format that I want to use to write the data out into object storage. Once I click configure, I'll be prompted to choose a cloud provider. You can see I can go with AWS or Azure, which is coming soon, and then I'll give it a name. So this is the name of the federated database instance that's going to be persisted, that actually runs the data and pulls it from MongoDB clusters and pushes it into object storage. So I'm just calling it my Parquet pipeline for the MongoDB Airways. Then I go and I select the cluster, which we just saw, and I say that I'm going to pull from all collections. Importantly, you'll see it also says I'm going to use a read preference of secondary, because I don't want to impact my production workloads that are running on the cluster. What it also means by selecting all collections is that as I add new collections to this cluster, they will automatically be picked up, and I will pull data from them and write them to new locations inside of object storage as well. Once I click next, I'll go to the setup to connect to my AWS S3 bucket. This will also work for Azure object storage eventually also. I'm just quickly going through and validating that I have access, because I've already actually set up this connection. So you can see I see 2 green check marks, one for role authorization and one for the S3 bucket policy. You'd have to set both those up, but since I've already done this, I just plug in the name and I hit validate. Once that's done, I select the frequency, and I'm going to write out from my collection every minute. I'm then going to choose the file format, which is Parquet. And I'm not going to skip catch-up events. If an event gets missed by the trigger, I want it to try and rerun that event. Parquet, for those of you not familiar, is a columnar-oriented file format that's really effective for storing analytical data in object storage. I'm then going to select a max file size, so the largest file I want to be written. If it goes over 100 megabytes, I will just write another file. Then I choose the location in my object storage, and I choose the field with which I want to base my $out runs on. And so I'm going to use the _ID, which a great feature of _IDs inside of MongoDB is that they are usually object IDs, which include a timestamp, if you're familiar. And so I can just use that timestamp, which is when that document was created, and pick that up in this job and write out a collection of these documents to object storage every time the trigger runs. Once that's done, I'll click continue, and I will see a summary of everything I just set up. So I connected to my cluster, I chose the object storage, set the destination and schedule, and then I hit go, and I'm done. At this point, I've set up a trigger and a federated database instance. I've connected the two, and I can now run these triggers on an automated basis to extract data from my operational cluster, from the secondary, writing it into object storage. And then I'm going to go over into the data federation menu, and you'll see that I already have a data federation card here, which shows that 29 queries have already been executed, and I've written out a bunch of data based on that. If you go into triggers, you'll see alongside my create bookings trigger, which was creating the sample data, I also have a new trigger, which is handling the writing of this data into object storage. What's great about this trigger is we've generated all this code that gets you set up immediately. You're already writing data into object storage, but we've also given you the flexibility to change anything that you want. If you want to extend the range of time, if you want to change the destination, if you'd like to change the source of the data, all of this is available to you. So there's no one-way doors here. You're setting up a trigger, and as you'll notice, I've actually commented, or the $out stage starts as commented out. Once you uncomment it and click run, it will start writing data to object storage. So I've uncommented it, I click run, and now if I navigate over to AWS S3, you can see I have my S3 bucket, and before the trigger ran, you'll see that I have no files in the bucket. But once I've clicked save and it should have run, then you'll see I have a folder, which is the name of my cluster, MongoDB.local. Then I have my database and collection. And then inside the collection name, I have a timestamp, which is when this data was written. And so this is captured, and then inside this final folder, I'll have a Parquet file, which is the data that came out of the pipeline. And I believe that's it. So you saw from the beginning to the end, copying data from your MongoDB application data into object storage to persist for downstream systems to consume. Now, to continue on, I'm going to talk a bit about what's new. So you just saw our templatized onboarding flows. We're really excited about these because what we've heard from customers and seen in the past is that it's hard getting started. And so we wanted to take all of the complex concepts and systems that you have to learn about and understand and get into, get an understanding of in order to build out this solution and put them into a streamlined, graphical user interface that customers can just run through and set up. And so that's what we've done with templatized onboarding. We have 3 different flows that are available today. One is exporting data to S3, which is feeding downstream systems, which you just saw. There's sample data flows. There's also the ability to query across multiple clusters. And there are going to be additional use cases to follow. We're really excited about the idea of custom archival solutions that allow you to set up the copying and deletion of data from your cluster and moving it into S3, and then seamlessly setting up a merged view between the data in object storage and the data in your cluster. And we're also really excited about the idea of materialized views. So materializing data from object storage, which is going to have slow query response times, back into your cluster for queries on an ongoing basis. So you can take kind of huge sets of data and materialize them into a cluster for really fast response times. The other thing that we're excited about is Azure. So for a long time, we've only had support for AWS for Atlas Data Federation. The service runs entirely on AWS, meaning that both the compute engine that is running these queries and processing the data, as well as the underlying object storage that we are able to connect to, was all AWS. We're thrilled that we're now going to have Azure support, so you'll be able to have the compute for your queries hosted in Azure, and so all of the query processing and data will stay inside of Azure when you're trying to run queries over Atlas Data Federation, which will improve performance, reduce data transfer costs, and maybe most importantly, also enable us to add support for Azure Blob Storage. So you can now connect to the blob storage support that's inside of Azure, kind of the complement to AWS S3. You'll be able to connect using an Azure Service Principal, which is similar to the AWS IAM role that you use to connect to AWS S3. And we will support querying data in any of the supported formats on the platform. So JSON, BSON, Parquet, ORC, TSV, and Avro will all be supported. And that's it for new features. So just to kind of summarize, what we learned today is that, inside of Atlas, there is a simple and integrated way to eliminate the need for manual ETL while still allowing you to have a holistic view of all your data. There's the ability to have enhanced productivity with what we saw MongoDB Airways overcoming the challenges of fragmented data in different places. And we saw what is effectively a really cost-effective solution. All of the services that you saw are consumption-based. So triggers and data federation, these are all only charged based on what is used. So really you're only paying for the services that you're utilizing. And we're really thrilled to have this new accessible way to access the data that is in your platform. And with that, I just want to put this up here for a second. These are a series of QR codes that link to different resources to help with getting this set up. So documentation, MongoDB University, the community forums, and a place to submit feedback. And then the last bit that I'll put up is our questions slide. So we will take any questions from the audience at this point.
I guess we were presented very clearly.
Yes.
So clear.
Here we go.
Will you have a support for the blobs file, like the PDFs that get stored in the FS files and FS chunks?
I heard blob storage and I heard PDFs.
Yeah, those PDFs that gets uploaded to the MongoDB,
Yeah, we don't support PDFs as a file format. We do now support Azure Blob Storage. I'd be interested to know kind of what you would expect out of PDF support. So I'd be curious to kind of discuss that further.
Sure.
Yeah.
This is basically to reduce the footprint of the database and just store it on the S3.
Yeah.
And then
Do all your PDFs have like actual text data inside them, or are they image? Because PDF is like a format.
Yeah, just the image, like the
just the image.
Yeah.
Yeah, so I think we would have to do something special to support the ability to process the actual PDF image and then convert that into textual data. All of the file formats that we support, like CSV, Avro, JSON, et cetera, those are text formats that we can parse those file formats and pull from. If we were to add something like PDF where we supported images and such, we'd have to use some sort of OCR technology and stuff like that. So that's not something we're doing today.
Okay.
Hi, does Atlas Data Federation support like custom transformations on the data coming out of Atlas before it goes into like S3? Or is that more of a Atlas stream processing question?
No, good question. So inside of MongoDB databases, we support a dollar function aggregation stage. That actually uses a JavaScript engine inside of server. Atlas Data Federation does not support a dollar function. We don't have a JavaScript engine hosted inside of this architecture. We do support the full richness of the aggregation pipeline though. So anything that can be described or formatted inside of ag, projecting fields, adding fields, computing sums, doing groups, anything kind of within standard aggregation, we do support. Also, anything that is being sourced from a cluster, so any data that you're pulling from an underlying cluster, we support the full expression of the aggregation pipeline. And what I mean by that is, if you're querying an individual cluster and you do want to run a dollar function, we will actually push the dollar function down to the underlying storage and execute it before we write out. So if, for instance, your use case was you have a bunch of data on MongoDB, you want to do some really complex formatting that you can only express inside of JavaScript, inside of a dollar function, you would be able to do that. We would push that stage down to the cluster. It would be executed locally, and then the results would come into Data Federation, and we would write them out to S3 or do whatever it is you wanted with them.
So that would put load on the cluster itself then?
I'm sorry?
That would put load on the cluster itself then, the running
That
of those
would
things?
put load on the cluster itself for the dollar function stage alone.
Okay.
We are exploring opportunities for adding external functions, and I would be interested in talking further after if this is interesting.
Yeah. Thank you.
Any other questions? You don't want to make me run? Great. Well, one more. Oh, were you pointing?
Do you want to put up the?
Oh yes, sorry. And then please take a look at the QR code for feedback. We're definitely interested to hear any feedback that you have about the session. So please take a look at that.
Awesome. Thank you so much. Give a round of applause to Ben and Taylor.
Thanks everyone.